Welcome everybody to another video in the Mockito series from Tales from the Jar Side. I have to tell you what was going on in this one. It turns out I was teaching a training class. My name is Ken Cousin, by the way. Thank you for coming. And somebody brought up the issue of testing business logic that was also invoking a logger. They were calling info or debug on a logger to get some log information out, and they wondered how they would test that as well. Now, there's issues involved in checking the output from loggers and things like that, and I'll get into that. But let me start off by saying this is a perfect example, or I should say, I suppose, a perfect opportunity for seeing how spies work in Mockito. Many people have heard of mocks and stubs, and I've used those in other videos in the series, but I haven't yet used a spy, and let me show you how they work. Now, this is the Mockito homepage at mockito.org. It redirected to site.mockito.org. And to get to the documentation, that's hosted at javadoc.io. So here's the Java docs, and it went directly to the Mockito class, because at the top of the Mockito class, they have this list of contents of all sorts of informational messages. One of them, number 13 here, is spying on real objects. When I access that, there's some code and everything, but let me just show you the important part. It says you can create spies of real objects. When you use the spy, then the real methods are called unless the method was stubbed. Now that unless the method was stub business has to do with the issue of partial mocks. That can get risky. We're not interested in that right now. As they point out here, real spies should be used carefully and occasionally, for example, when dealing with legacy code. Well, let me show you how this works. What I have here is a class called logging demo. Now, I've made one concession to make this easier to test, and that is the logger I'm planning to use is set here as an attribute which I'm going to plug in via a constructor argument. It's easy enough to rewrite my code to make that possible. That makes the testing much easier. So here's the business logic method. This method called doStuff takes a string. It prints out doing useful stuff with that string, whatever it is, and then invokes the info message, or the info method rather, from Java util logging logger, takes a string message and returns nothing. Now, as you see, I'm using Java util logging, but the mechanism I'm going to show you here works on any logging framework or pretty much anything. It was easy since I was already using the JVM to just stick with the logging library that comes with the JVM, comes with Java. Now, there's a couple problems here to make testing difficult. First of all, you'll notice that info returns void. So there's nothing coming back. It doesn't return the message that it's logging. It just writes it to whatever handlers are available. Secondly, the doStuff method also returns void. And it's really hard to test methods that don't return anything. I mean, what are you going to check? Usually when you test a method that returns void, you do it by checking the way the state of the object changed by calling this method. But the only attribute this class has is a logger, and it's final, and it doesn't change just by calling the info method. So testing it's going to be a challenge anyway. Well, never fear. Here is my logging demo test. So I make a logger, sure, and then here in the first test called test log, this is trying to deal with the fact that nothing's coming back, so what the heck can I test? So I instantiate the logging demo with that logger, and then I'm going to call doStuff. But again, because nothing's coming back, about the only thing I can do is appeal to JUnit 5's assert does not throw method, which takes an executable. See, that's the lambda here where I put in no arguments and then invoking doStuff. And all this does is assert that calling that doStuff method doesn't throw any kind of exception. I mean, good, that's reassuring, but not all that helpful, not all that useful, but it's something. Here, however, is where we get to use a spy. So this time I'm using the static spy method from the Mockito class, which wraps an object of type T. This is a generic type, and then it returns that object. That means that whatever I was going to do with the object before, I can do now. I get back the object from the spy method, and I can plug it in to the constructor, just the way I intended to before. Then I invoke the method I want to test. But here's the difference. You can verify a spy just like you could verify a mock. What I mean by that is the verify method from Mockito takes a mock, or in this case a spy, and allows you to verify that, for example, some method with some arg was invoked on the mock exactly once. It could be a number of times greater than one, but if times is one, then you could just leave that out, and that's the default. So here I am verifying that on that spy of the logger, the info message was invoked with the hello world argument exactly once. And if you take a look at my logging demo, the message was just passed straight to the info method. So that's exactly what happened. I could have written in the times one, but you see that isn't strictly necessary. So if I run these tests, what you will see is that there's the standard out print, and there is the actual log that went on, but my test passed because I was able to verify that the info method was invoked with that argument exactly once. Now, some people might look at that and say, well, that's good, but you know what? I kind of would like to capture standard out or standard error. See, that's the weird part down here. You'll notice that system.out.println goes to standard out, which is in white in this scheme. But it's always been odd to me, but it's true, that Java loggers always log to standard error for some reason, even though I'm clearly at info level. So I kind of need to capture both. And what would I do there? Now I'm going to address this, but then we're going to come back and talk about whether that was even needed or not. So first of all, I have a test here. Let me get this out of the way, called log standard error test, and standard out, as a matter of fact. So I made my logger and I plugged it into the logging demo, but this time I'm going to create a couple of byte array output streams called out and error, and set the out in the system to print streams wrapped around both of those. Then when I call my method, I can go and convert those output streams to strings and verify that they do in fact contain the strings I'm looking for, and then I reset them because I don't want to affect any other tests or anything else going back on there. So, okay, this works too. It's a little verbose and a little awkward, but it does seem to do the job. If you happen to be a fan of the Spring framework, then there's a somewhat simpler mechanism. The Spring Boot test framework includes a Mockito extension, actually, a JUnit extension called Output Capture extension. This is from org.springframework.boot.test.system, and it's a JUnit Jupyter extension to capture system.out and system.error. You could register it with a test class or even an individual test method through extend with. It does parameter resolution for captured output, which can be used to assert the correct output was written. So what I've done here is in my test, I put in an argument of type captured output, go ahead and make my logger, plug it into the logging demo, call my business logic, and I can assert that the output stream and output capture contains the string I want, and the same thing with the error stream. I could check that that contains the right value as well, and that passes also. So nice. I mean, that's good. It did mean I had to add the Spring Boot testing dependency to my project, but not a big deal, and it works. But let's talk about this a moment. Why do I need to capture the output at all? Why do I need to capture the logging output? Remember, I'm not really interested in testing the logging framework. I trust that log4j or SLF4j or logback or even Java util logging will do what it says it does. All I really need to check, as I did in the first test, is that the info method is called with the message I expect it to log. And I can do that with just a spy. So yeah, I went to all that extra trouble to go ahead and capture the output, but it really isn't necessary in this case. I just need to spy on the logger and make sure the method was called, and the rest is testing the logger, and I have no great desire to do that. At any rate, that's how spies work. That's the easiest mechanism. You can actually use spies to override certain methods to behave a certain way. We're not going to get into that, but it's available. All this code is part of the GitHub repository for my Mockito Made Clear book, which is listed at Pragmatic Programmers. And here, in fact, are the links for this. There's the book link as well as the GitHub repository. If you have any feedback on this or any comments, or you have any opinions about how this should be done or not done, please feel free to let me know. I'd love to hear from you. Otherwise, thank you very much for listening to this, and I hope you enjoy it. I'll see you in the next video. Take care.